Okay, hi everyone. I want to talk to you about what a polynomial function is, and it's pretty straightforward. We've dealt with polynomial functions before in relationships to um, specific types of polynomial functions, such as linear and quadratic, as you can see down here. And then we're going to introduce you to what's called a cubic and a quartic. But in general, let's give you a definition. A polynomial function is basically a function in the form of f of x equals a sub n times x sub n plus a sub n minus 1, x to the n minus 1, all the way down to a sub 1 x plus a sub 0. Now, that might not make a lot of sense, but basically what you need to remember is all of these a values are different numbers, so they're the coefficients. And these x's are the x variables raised to the exponent. So if this one was x to the third, this one would be x to the second. Okay, so on and so forth. A couple of things that I want to note. First of all, what a sub n is. We've talked about this before. If we have a polynomial and it's written in descending order, the first number out here, we call that the leading coefficient. And the n right here, the highest power that's listed, remember we call that the degree of the function. So I'm going to go ahead and highlight a couple of things right there. This n value is my degree, and right here, this number that's out front here, right there, that is my leading coefficient. And we've dealt with polynomial functions in terms of constant function. So here's an example of constant function. This is the standard form, by the way. I'm not really concerned that you can recite the standard form. It's more important that you can look at a function and say, is it constant, is it linear, is it quadratic? And so here's an example of each of those. Excuse me. Constant function is just f of x equals a number. Straightforward, no variables in there. A linear function, y equals mx plus b, or f of x equals mx plus b. So there's an example of a linear function. Quadratics, man, at this point we should know what these things are. Ax squared plus bx plus c, or a2x squared, a1x plus a sub 0. So instead of a, b, and c, you can use a sub 2, a sub 1, and a sub 0. But more importantly, you should be able to look at this and say it's quadratic. A couple of things to mention. First of all, on this one, my leading coefficient is negative 14. My degree is 0 because we technically have an x to the 0 in there. This one, my leading coefficient is going to be 5, and my degree is going to equal 1. This one right here, my leading coefficient is 3. My degree is 2. And that's what we've been dealing with so far. I want to introduce two new ones to you. And the first one is when we have a degree of 3, and we call that a cubic. Okay, think about cubing something, cubic. And the general form kind of looks like this. It's f of x equals a sub 3x to the third. So 3 is our highest exponent. Plus a sub 2 x squared plus a sub 1x plus a sub 0. Okay, so you're looking at a function that has a degree of 3. We call those cubic functions. So an example would be negative 7x to the third plus 2x squared minus 7. Notice there's no x in there, but really there is. There's a 0x. Here, once again, if we look at our leading coefficient, is negative 7. And our degree here is 3. Okay, highest exponent is 3. We call those cubic functions. The next one, if we have a degree of 4, we call those quartic. And what that means, if I want to write out the general form, is that my highest exponent is 4, so a sub 4, x sub 4, and for time's sake, it's all that other stuff plus a sub 0. So the key thing to remember is degree of 4, highest exponent is 4. So a quick example of that would be something like this. F of x equals negative 2x to the 4th plus 3x squared minus 12. You can see my highest exponent is 4. So this has a leading coefficient of negative 2. Okay, it's written in descending order. This has a degree of 4. So that's the idea of the two new types of polynomials we'll be looking at in this unit. Third degree, we call them cubic. Okay, and fourth degree, we call them quartic. And a couple of things we're going to be doing with them is the first thing we're going to do is we're going to look at some equations, some functions, and see if they're a polynomial function. So remember what a function is. It's a one-to-one ratio. We've been dealing with functions a lot. Polynomial is a subgroup of them. Okay, and what we want to look for is we want to look for variables here. Okay, and we also want to look at their exponents and determine if their exponents are all whole numbers, meaning 0 or above. So if I look at this first one here, is this a polynomial function? Yes, it is. If it is a polynomial function, we want to be able to write it in standard form, find the degree, list the type, linear, quadratic, quartic, cubic, and also the leading coefficient. So if we rewrite this in standard form also means descending order. So let's put that in there. All right, so descending order, highest exponent to lowest exponent. This one's already written like that, so let's just go ahead and recopy it. Negative 2x cubed plus 5x plus 8. So there it is, standard form. My degree is 3. My type, since it's a third degree polynomial, is cubic. And the leading coefficient is negative 2. Okay. Looking at the second one, if you look right here, that tells me that it is not a polynomial function. 7x to the negative 1, the exponent is not a whole number. Isn't whole number. A whole number is 0, 1, 2, 3. So basically we can't have negative exponents and call it a polynomial function. Okay. Third one, is this a polynomial function? I look at my exponents 3 and 4. Yes. Rewrite it in standard form. Highest exponent to lowest. So square root of 2x to the 4th minus 0.8x to the 3rd minus 12. Excuse me. All right, so what's next? So the degree. Degree is 4. The type is quartic. And my leading coefficient is the square root of 2. Okay. Finally, the last one. Is this a polynomial function? No. Boom, right there. 3 to the x. No variables in the exponents. Okay. All right. So one thing you're going to be asked to do is to classify them. So you got to write them in standard form. Tell me the degree. Tell me the type. Tell me the leading coefficient. Another thing you're going to have to do is evaluate. And I'm not going to spend a lot of time on this because we've done it before. So if we want to evaluate this function when x equals 3, basically they're saying plug 3 in. So 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. Plug all of this in your calculator exactly like it looks like in one step. F of 3 equals 98. Okay? Verify that on your calculator. For the second one, we would want to plug 4 in there. And I'm going to have you guys do that. So pause this. And you should get negative 129. Okay?